So good day, folks. So today we're going to be looking at this problem here. So we're asked to find the speed and direction of the output gear. So this is the output gear, and we're supposed to find the output torque as well and the output power. So we want to find three things. So output gear 9, we want to find the speed and direction, and we want to find the second thing we want to find is the output horsepower. And third thing is the output torque. Okay, so let's go quickly over the problem here. So we've got a pulley. 2 is a pulley, 3 is a pulley as well. We've got a belt going through here, and it's spinning clockwise. So it's clockwise, and speed is at 1200 RPM, revolutions per minute. And the input PN, the input power, is 1.5 horsepower. Okay, so if you follow along the cursor with me, so this is clockwise, that means it's going so it's going clockwise, that means it's going up and down like this. So it's rotating this way. So that means it's going up like this, and the same thing here. So this is going to be going clockwise as well. So that means this baby here is doing the same thing, so it's rotating clockwise as well. So if it's rotating clockwise, that means it's pushing out of the page. If that makes sense. It's pushing out of the page. Hence, this gear here will move in this direction. It'll move like this, if you know what I mean. Now, so short symbols, I'm going to make this like this. And now this rotation is followed down here. So this guy is spinning, let's see. So if I look at it from this axis here, it's going in this direction, it's going clockwise again. So if that's going clockwise, that means this is going to be the opposite of it. Now, we look at the worm gear. Now this is the worm gear, and it's got 3 tooth. It's a 3-tooth worm gear. So if this guy is rotating this way, that means it's rotating. So if I look at it from this side, from this direction, okay? If I look at it from this direction, it's rotating clockwise. So this guy is going to be going clockwise as well. So whatever this direction is spinning at, if you look at it from this direction, it'll match this direction here. So now at least now we know the direction, which is clockwise. Now in order to find the speed, we need to go through the train ratio or the gear ratio. So let's do that. So train value, or yeah, sure. So let's define that first. So it's the speed of the pinion divided by the speed of the gear, or N is for speed, okay? So N is for speed in RPM. So, or N in over N out and that's also equal to the number of teeth, sorry, of the pinion, of the gear. No. Number of teeth of the gear divided by the number of teeth of the pinion, and that's the diameter of the gear divided by the diameter of the pinion. Okay, so let's do that. So based on this, so the train value is basically equal to the velocity ratio 1, velocity ratio 2, and velocity ratio, like whatever n value you have, okay? So like that's VR, and that's more like it. Okay, so let's do that. So train value. So the first one is a belt. So we have a small pulley, and we have the larger pulley. So we're going to do, so the smaller pulley is the input, right? And what do we know? It's the end. It's the pinion, and that's the gear. So basically, in, out. So this is in, and this is out here. So let me get rid of all the, this stuff here. Okay, so this is going to be your out. So we have the diameter, so we're going to use the diameter. So we have, so remember that NG here is the it's the out, right? It's the gear. So in this case, if I look at the G and the out, that means we're going to go 10 inches divided by 6 inches times. Now look at the second thing. We're going to look at the bevel gear here. So this is the in. So let's get rid of this now. Let's focus on the second gear set. So we've got a bevel gear, and this is the let's look at the this is the in, and this is going to be the out. So what do we have? We have the number of teeth, okay? So this is called the pinion, basically, and this is called the gear, right? They're both gears, obviously, but whatever gear is doing the input, we call it the pinion, or the smaller gear is usually called the pinion. Okay, so usually the smaller gear called the pinion. Okay, so now doing that, what do we do now is okay, so we're going to go, so the number of teeth of the gear, so that's 38 teeth divided by 18, right here, 18 teeth, okay? And then multiplied by, we're going to look at the last, look at the last pair here. The one just before the last pair. So we've got, so this is called a spur gear. So this is the just to be clear, so this was the bevel gear, and this is spur gear now. So spur gear, it's a straight spur gear. Okay, spur gear set, basically, or set, because there's a input. And the last one here, this one's called the worm gear set. Obviously, the other ones are called like spur gear set and then bevel gear set. This is a pulley system. So let's get back to our focusing on finding the. Okay, so we've got the bevel gear, we've got the pulley system. We're going to focus on the spur gear. So again, this is going to be the input, and oh man, is going to be input, this is going to be output. Out. Okay, so if I look at the output, which is a gear out, it's 48 teeth divided by 20 teeth. And now, finally, let's look at the worm gear set. Same thing. This is the out, this is the input. And doing that really quickly, we're going to get 36 over 3. If I calculate that really quick, so 10 divided by 6 times 38 divided by 18 times 48 divided by 20 times 36 divided by 3, we get 101.333. So that's your train value. So now, going back to this formula here, so I'm going to take this all, and go to copy, and go to the next page. Get it back on here. Voila. Now, so remember this formula we had. So it's going to be n in, speed in, or speed out. So we know this value. We know this value. Now we just need to find. Sorry, we don't need. We want to find n out. So we know this value. Now we want to know what this value is. So if we solve for n out, which is equal to n9, which is what we want, so which is equal to like gear 9 basically. That's speed, right? And what we find is 101.33 times, what was the input speed? 1200 RPM. No, yeah, that's wrong. So you know the gear value. So let's do this again. Okay, switching these two. So that's 1200 over 101.33. Let's do that. That's 11.842 RPM. So that's your output speed. So now we're down to finding the last two items. So we've got the speed. Now we want to find the output horse and the output torque. So in the problem, they give us the so they give us the overall efficiency, which is equal to E is equal to let's see. They tell you it's 0.08. Okay, so they tell you it's 0.8. So we know that efficiency is equal to basically P out divided by P in. So we have P in, we have the efficiency, we can find P out. So let's do that. Okay, so the efficiency is 0.8 times power n. How much was the power n? Let's go back and see. 1.5 horsepower. So 1.5 horsepower. So what do we get? 1.5. That's 1.2 horsepower. So we've got the third answer. Now finally we want to find the torque. So in order to find the torque, so we have this relationship with the torque. So torque is equal to the horsepower over the speed. And rad per second. And and that's in pound. It's in the what's the horsepower in pound? I think pound feet per second. I think that's what the power is. Double check this, okay? So double check this. Not positive about this one. So if we do this now, formulas. So after conversions, you can figure this on your own if you do the conversion. So power out, obviously, we're going to do 1.2 this here, and divided by 2 pi, because we're converting the speed, the output speed, to radians per second. So it's 11 point. Actually, we're converting it to radians per minute. I think that's what it is. It's radians per minute. Yeah, double check this too. Okay, so then 11.84. If we do the calculation for this, 33,000 times 1.2, 2 times pi, 11.84, and we get 532. 0.1 and pound foot. That's your torque. And that's the end of the problem. If you have any questions, write them down in the comments below, and thanks for watching.